All right, when you're looking at this problem, you have the pattern of SSA. So that means you're going to use the law of sines, but there might be one or two solutions. Remember, the way to figure that out is if the side opposite the given angle is smaller than the other given side, you have two triangles. If it's larger, as in the case of this problem, you have only one triangle. So this is going to have law of sines, but only one solution. Okay, so we can find that solution by applying the law of sines. We have our set ratio right here. And so the piece of information that we need to, or actually, in this case, we're just looking to find the area of it. So given this, we need to find the pattern of SAS in order to apply the area formula. So we need SAS for the area. And so we need to find one more side. So in this particular case, we either need angle B or we need side B. So in looking at this, we have to find angle C first. So I'm going to use my sine law of sines to find C. So I'm going to start with my unknown. Sine of C over the side opposite at 16 is equal to the sine of the known angle 66 over the side opposite at 20. And we're going to solve for angle C. However, our calculators won't do that. So we need to let x equal the whole sine ratio of C. And we're going to try to solve in this case. So if we type this in, the F2 algebra tab solve, x divided by 16 has to equal the sine of 66 divided by 20. I'm going to put a decimal in that and identify that I want to solve for x. Now, again, this should display my sine ratio, which I expect it to be between -1 and +1. Okay, this is consistent. 0.731 is my sine ratio, which means my angle measure itself can be found by taking the inverse sine of that ratio. So green diamond y is my inverse sine. Highlight, I'm just going to write of x, use my with key, and then highlight what x is equal to. Again, just saves a little bit of time from trying to delete the x equals. And I get my angle measure, 46.96. Angle C. Okay, now, in order for me to fit this pattern, I need SAS. So I either need to find this side right here, or I need to find this angle and use small c, angle B, and small a, which is what I'm going to do. I can find angle B very easily, right? I can just take the sum of the angles, 180, subtract the given angles of 66 and the one that we just found, about 47. And I get that what remains here is 67.04. Okay, so there's my angle. And so the pieces that I'm going to use to solve this are S, A, and S. So I'm going to use those three pieces. My area formula is 1/2 the product of any two sides. So here I'm going to use side A and side C if I'm writing them with the correct letters. And then all times the sine of the angle between those B. Okay, so plug in the values for these. So 1/2, A is 20, C is 16, the sine of angle B, which is 67.04. And when I calculate that, 0.5 times 20 times 16 times the sine of this angle, I get my area to be 147.33 approximately square units, since I'm dealing with a two-dimensional measure.